starts to look somewhat complicated. I now have a circuit board, ripcord generator, multimeter, data collector, but it is a pretty good lab where students are going to dive into how we use motors, essentially spinning objects, to generate electricity. This will really help students make the connection, let's say for like windmills. Okay, how is a windmill actually creating electricity? Wind blows it, it spins, and it has a series of alternating magnets where that creates a current, alternating current, as they're about to find out, and then we can harvest that electricity. It's the simplified version of it. So these things just slot right onto your board. I'd recommend you do that because as you pull the ripcord generator, the extra weight helps keep everything still. It's also nice to have so that way your leads to your multimeter just kind of stay connected to the metal bits of the coil there. So for the first part, students are just going to investigate what does the output look like in terms of direct voltage versus alternating voltage. So to wind this up, just kind of get it around a few times so that way it's a little bit tight, and then just keep the tension on as you spin it around. Once you get the hang of it, it's not that bad. And so right now I'm going to start off with direct current. And if you pull on it, you'll see my direct current floating around 0, but it just can't really make up its mind. You switch it over to alternating voltage. Now it's more consistent. It's slowly dropping, 0.5, 0.4. And so actually what we're getting here is an alternating current because the magnets are flipped each time. And so each time a magnet passes by, it's switching which direction this magnet, electromagnet is picking up, and that creates a current which then is getting picked up. So kind of a cool way for students to discover alternating current, how motors work, has a few questions that help them visualize that. And then the second part, we bring out our photo gates, and these have a slot that it fits right into here. There's a blank space in the middle of the motor. You'll see as I place it underneath this, it turns green, and then it does a full lap before it picks it up again. So this is going to be measuring the frequency of the spins for the second half of the lap. They're still going to have this set. I have it set to the alternating current for voltage set at the 200 in order to pick up some decent numbers. I'm going to go ahead and wind this up again. Move the center if you need to get him wound up. There we go. Placing him back in. So just make sure that you go to the CPO timer mode, set it to the F at the bottom for frequency, and then that is set up for the rest of the lab. Students will be collecting different voltages as they do the different rotational speeds. So as we pull it, I can measure my frequency at 20. What's my voltage reading at that? And so it's just a matter of gathering all that data. Maybe it takes a couple trials to get some of that, and then they can all visualize the results. I'm not gonna like showcase the last of it, and I might recommend not doing this part with the students because it involves taking this apart, removing magnets, changing their orientation. I would just say keep all the magnets how they are in this. It's not hard to undo, but you don't want magnets getting lost, and then you have a generator that's not full. So perhaps skip the end part of it unless you have advanced class that you think could handle that, or you have multiple set up like stations that have already got the magnet set for students. That might make it work a little bit better. But a pretty good introduction to alternating current and how motors work. Collects good data, so pretty good lab overall. Let me know what you guys think, and I'll catch you guys in the next video. Bye.